Okay, day 6 lesson. Solving triangles is what this is all about. Now, solving triangles means to find unknown sides and angles. You'll be given certain angles and sides, and you will find unknown sides and angles. Now, some of the information on here, we're going to do law of sines, law of cosines, Pythagorean theorem, right triangles, basic trig. So, law of sines, law of cosines. This is relevant to that. And yeah, so that's on that note sheet from day 1, but any of that information has been copied onto this note sheet. So for tonight, we're just going to do all degrees, even though I know we're easing into radians, but for tonight, we're going to do all degrees on today's assignment. So calculator will be in degree mode. We will be using calculators to find decimal answers, but we'll try and find exact answers as much as possible. It'll just be kind of messy. So, right triangles, Pythagorean theorem, a squared plus b squared equals c squared. The sum of the squares of the legs equals the square of the hypotenuse. There are things called Pythagorean triples, which are right triangles that have all sides that are integers that, follow the Pythagorean theorem. 3, 4, 5 triangle is a Pythagorean triple. That's a right triangle that has legs of 3, 4, and a hypotenuse of 5. 5, 12, 13. So I guess, and I don't know, I wouldn't remember most of these. 3, 4, 5 is the one I kind of recognize. So I'm saying it's okay to use that, I guess. Otherwise, you could do Pythagorean theorem. SOHCAHTOA only works for right triangles. So what we're going to be focusing on today, and we've solved some right triangles before, back on like the first day, I think. But now we're going to solve non-right triangles. So how do we solve a non-right triangle when we can't use regular basic trig and Pythagorean theorem doesn't apply anymore? So the idea here, and I'm not going to get too much into it, this should have been derived probably back in Algebra 2, maybe pre-calc, where you take a non-right triangle and you split it into 2 right triangles, which can always be done, and then you apply SOHCAHTOA to these sides to find the unknown side. And you can use Pythagorean theorem and SOHCAHTOA, sine, cosine, tangent on the 2 right triangles and come up with relationships between the 3 sides, the 3 original sides and 3 original angles. And one of those relationships that's derived from that is law of sines. And it simply says that sine of angle A over the little a, which is the side across from it, equals sine of b over little b equals sine of c over little c. So, so we call these the opposite sides from those angles, and we tend to try and use the same letters to indicate that. Now, capital letters are usually used for points in geometry, and lowercase letters are often used for variables for lengths or sizes of things. And so that's sort of the capital letters for the vertices and lowercase letters for the sides. So that's law of sines. That's an easy one to remember. So as much as I can, I like to use law of sines because it's pretty simple and straightforward. But there are some situations where we can't use it. And this is what gets into, I'll explain why in a couple minutes. But if you go back to geometry, when you would have to do 2-column proofs, they're called direct proofs, and you'd have to prove that 2 triangles were congruent. There was some shortcuts you learned, like angle, side, angle, side, angle, side, angle, angle, side, 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 angle, angle, angle. I think there was a 6th one. Let's see if we can figure that out right now. Oh, yeah. ASS, angle, side, side. Now, law of sines cannot be applied to a couple of these situations. It can't be applied to side, 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 and it can't be applied to side, angle, side, and I don't think it's going to be able to be applied to angle, angle, angle. So we'll see how this works out. Anyways, so this only works for certain sets of information that are given to you at the beginning. If you're given information in just the right way, then you won't be able to do law of sines. But good thing is, when you can't use law of sines, That means usually you can use law of cosines. Now, we can often use law of cosines in the same situations we use law of sines, but law of cosines is a mess. It's much harder to remember correctly. It's harder to implement correctly, even if you remember it. But law of cosines looks like this. There's 3 versions of it. Really, I'd remember one version of it, or just remember one pattern. Look for a pattern. This is side of an angle over the side across from it. I'm not memorizing the letters. I just remember that basic idea. By the way, these could all be upside down too, and that's fine. But law of sines kind of looks like Pythagorean theorem, so I kind of use that to my advantage, but it's not always going to be the hypotenuse over here, by the way. It could be, in fact, it's not even a right triangle, so that hypotenuse idea doesn't even necessarily make sense. So any of these sides could be in that situation. It depends on what you're going to do over here. So a squared equals b squared plus c squared, and then you're going to do minus, you got to remember it's minus 2 times the product of these 2 sides that are on this side, times cosine. Now, if you put sine, I'm kind of worried because it's called the law of cosines, and you should probably have a cosine in it, right? Of the angle across from the side that's over here by itself. So it matters which side's over here because that's the angle that's going to be here. So you might choose the side angles to be here because of the angle they gave you or the side they gave you and the angle you want to find or whatever. Now, the other versions are the same pattern, b squared equals a squared plus c squared minus 2ac cosine of b, the angle across from this one. So really, it's one pattern. I would not memorize 3 of these formulas. I'd memorize one pattern, okay? Because they all follow that pattern. Now, I would say the easier one to use is law of sines, right? I mean, the pattern is easy to remember. It's, I think, just less messy. But there are some situations where law of sines is going to give us problems. One of those issues is that your calculator, and it goes back to one of these issues up here, is that your calculator can only gives you principal angles. And we talked about this before. And we've kind of created a workaround for that where we force it to give us the principal, the reference angle alpha by forcing it to be positive, but still, and then we just give all the answers for all the quadrants. But in these problems, there's really like one answer usually. And so we have to figure out what to do with that. So for instance, like in this problem right here, if we were solving this on our calculator and we did inverse sine, it would give us 60 degrees, which is an acute angle. But the problem is that in our triangle problems, it is possible that it might be the quadrant 2 angle, which is an obtuse angle, which is from an obtuse triangle. So which one is it going to give you? So your calculators will always give you this answer, even if it's not the right answer or the one you're looking for. So we have to be careful about when we use our calculators for law of sines, inverse sine, and I'll tell you how to avoid getting it wrong. We got some ways. So we would, which one is it? We would need more information to really know which answer it is, or maybe it's both. Okay, so we'll come back to how to avoid getting that wrong and getting that right every time. Okay, we have a strategy for that. Something else we're going to try and use as much as possible is the simple idea that the angles of a triangle always add up to 180 degrees. We'll always use this. Always use this to find the last angle. Because as soon as you have 2 angles, then you can always just add them up and subtract them from 180, and that will for sure give you the right answer. Okay, and that's one of the ways we're going to avoid getting the wrong answer up here. Okay, so if there is an obtuse angle, there's only one at most, and it's the biggest angle. And so we'll try and use the sum of the angles of a triangle out to 180 to find that last one. Okay, now unique solutions. These are situations where you're for sure going to get one right answer. Okay, and these boil down to the 4 shortcuts you learned in geometry to prove that 2 triangles are congruent, the ones that worked. So one was side, 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 angle, side, angle, angle, side, which is, by the way, the same as side, angle, angle, and angle, side, angle. Okay, these are the four situations that in geometry you could use to prove that two triangles are congruent. And in this situation, that means there's only one possible answer, because that's why they worked as shortcuts in geometry. Okay, now you gotta make sure that the order of these letters matters. This is the side that's between the two angles that you know are congruent, and this is we call that the I don't know, I forget the name for that, the fancy word for that. This is the one that's not between them. Okay, so the order matters. Anyway, so we would draw pictures like this back in geometry, where this would be angle, angle, side. And there would be another triangle, angle, angle, side. And they would be congruent without much information. Technically, for two triangles to be congruent, all their sides have to be congruent. Corresponding sides have to be equal and congruent. And all the corresponding angles. That's 6. But with 3 things, we can prove with the right 3 things that those two triangles are for sure congruent. Okay, now if you didn't have one of these 4 situations, that doesn't mean the triangles aren't congruent. It just means you can't say with that limited information. Now, the ambiguous case back in geometry, the ones where it was like, well, we don't know if they really are congruent or not, one of those was ASS, which I feel like was kind of easy to remember. So ASS did not work up here, and triple angle didn't work either, okay, because they could have all the same size angles but be bigger or smaller versions of each other when it comes to the sides. So ASS was a unique situation because, and I'll draw some pictures here. I want you to understand this because that's going to help you do better on this. Memorizing the formulas and stuff is going to fail you. You're going to have a harder time. You're going to be slower. You're going to get problems wrong. Okay? Like for not tiny mistakes, but big mistakes, which I'm going to take off lots of points for. So make sure you understand why these work and why they don't work. Okay? Now, in the ASS situation, it could be that we have one unique solution, or we could have 2 different correct solutions, or it is possible that we have no solutions, which means it just can't even be a triangle. Okay. Now, I know I'm talking about 2 triangle issues, but I'm just connecting it to why those reasons work back in geometry for proving 2 triangles congruent. We are actually only working with a single triangle here. But so in this case, ASS, you have an angle, a side, and then a third side. Now, here's why it's ambiguous, because that third side could be here and make a triangle here, or you could swing it over to here and put the same length side as this one and put it here, and it creates 2 different triangles, which is why it can't be used to prove 2 triangles congruent with only that information. But it is also why we might get 2 solutions on these answers. In fact, usually we probably will get 2 solutions. So this is the 2 solution case. You get 2 possible triangles. Okay, there is a special case where your angle, your side, and then your second side is exactly perfectly the length that just barely hits that side. So imagine this last side is swinging, and it hits it exactly once, which creates a right triangle. So that's one solution, which is a right triangle. Very kind of special case. The third possibility is you have an angle, a side, and then the next side that's swinging is actually not long enough to even touch this side. And that's no solution because you can't actually have a triangle. Okay? So this is what you need to watch out for on ASS, just ASS. Okay? So you don't worry about this on those other scenarios. So how do we know which of these situations it is? Now, it's possible that in Algebra 2, your teachers, you guys just kept looking for all the answers, and when something would go wrong, you'd be like, well, I guess it's just one solution or it's no solutions. I don't want you to just be doing tons of work until something goes wrong. I want you to know up front which situation it is, how many answers you're going to get. Because if you're doing extra work when it's only supposed to be one solution and it looks like you're looking for a second solution, I'm taking off points, even if you come to the right conclusion. Because I want you to be smarter, okay? So this is one where it's too short, and this one's just right, okay? Now, the key thing here is is that second side, that swinging, how does it compare to the height of the triangle, right? There's the height of the triangle. This one's exactly equal. This one's shorter than the height. So really that's all it comes down to. How do we know which situation it is? How do we know which situation it is? And so the way we do it is we calculate the height of the triangle and we compare it. So the height of the triangle, what we're going to do is we're going to imagine it's a right triangle and we're going to use basic trig. You have opposite and hypotenuse, so you'd want to use sine of angle A equals opposite over hypotenuse. Okay, now H stands for height, not hypotenuse, so be careful. And then H would equal the first known side times sine of angle A. So we just use basic trig to calculate height, and then we compare the second known side, the swinging one, to the height. And if the second known side is greater than the height, then we're going to get two solutions, and we need to look for them. And we haven't even talked about how to find the two solutions yet. We're just trying to talk about predicting how many we expect. If the second known side is less than the height, well, then it's not possible. Stop your work. No solutions. Okay? And if the second side is equal to the height, well, that's a one solution. That's a right triangle. Okay? And there's actually one other situation that could actually cut out a bunch of this work. If the second known side is bigger than the first known side, well, then it's one solution for sure. And I'll show you why. Because if the second known side is longer than the first one, well, if it swings, it's going to be back here, and that's not possible because you do need this angle set, this side set. This is the swinging side. And that second scenario here is just not possible. So if the second side is bigger than the first side, if this one's bigger than this one, then it's for sure one solution. And don't even calculate the height. Okay, so that's kind of a special case. So you got some things to look for. Now, remember your calculator gives you principal values, right? So the way to avoid or even having to think deeper or get confused or mistaken on these problems is to calculate the angles and sides, or the angles in order of small, medium, large. Okay, large, because we leave large for last because if there's an obtuse angle, which is where your calculator is going to fail you and give you the acute angle, save it for last, and we'll always use the sum of the angles of a triangle to get that last angle, and then that will always work. Now, if you're like, well, how do I know which angle is the smallest or the biggest? Well, there's this idea from geometry that says that if you have the smallest angle in a triangle, then the side across from it is going to be the small side, and the side across from the medium angle is going to be the medium side, and the side across from the biggest angle is going to be the biggest side. So that's always true, that the smallest angle is always across from the small side of a triangle, and the biggest angle is always across from the biggest side. Okay? Now, your assignment is on the back of this, but we have some other work to do first. Okay? So there's another handout that you should have that I would have handed out in class today, or might be included in the Google Drive somewhere in it. It has this stuff on the back. It has regressions on the back, which is actually tomorrow's notes, which you need a graphing calculator for. So we're not going to do that. But the front is all this tiny little work, and this is to help you. And we'll go through this right now. But this is to show you how to do the work for solving non-right triangles and kind of going through the different cases. And so I've put a bunch of it down so you don't have to write it all down, but let's just talk about it real quick. Okay. So if you have a non-right triangle, the very first thing I do is I use law of sines. Okay. I try and use law of sines. So even if I'm not going to be able to use law of sines, I'm usually going to be able to later. If I have to use law of cosines, I usually only use it for the first step, for the first unknown, if I have to. Okay. Otherwise, I'm using law of sines. So whenever I do law of sines, I set it up. I said, okay, let's start at law of sines. Sine of angle A over little a equals sine of little angle B over little b equals sine of angle C over little c. And once I set that up, one of the benefits is, one, I'm going to use it eventually. Two, it's going to tell me right away if I can use law of sines or if I have to use law of cosines. So you can memorize the situations where you have to use law of cosines first, but you don't need to. And so I would recommend you don't, because there's already enough stuff to memorize here. Okay. So here's an example. Now, when they give you a triangle, I would draw the triangle if it's not and label it with the things that have been given to you. And from that, you need to write down, well, which scenario is this? Is this angle, angle, angle? Is this side, side, side? And you say, okay, well, this is side, angle, side, right? SAS. Write that down. Because you want to write that down, because if it's ASS, you want to immediately start deciding if there's 1, 2, or no solutions. Okay? Right away. Okay? So then I would set up law of sines. I'd say, okay, well, sine of A, which I don't know, over little a, which is 10, equals sine of B, which I know is 100 degrees, over little b, this should be a little b, which isn't known, equals sine of C, which I don't know, over little c, which is 6. So I'd fill it all out. Now, if you look at this, now, if you're going to be able to use law of sines, you need to have two of these fractions, any two of them, where there's only one unknown. And these two, there's two unknown. And these two, there's two unknown. And these two, there's two unknown. You can mix and match. But since none of them, you need one of these fractions to have all the numbers. And since none of them have it, that means you're going to law of cosines. Okay, this is the time where you have to do it. So we're going to do law of cosines. Now try and remember the pattern. Now here's the deal. You know you have angle B, so that has to be the angle over here. And I would try and write this down with all the letters, not by memorizing all three different variations of law of cosines, but remember the pattern. I'd be like, okay, well, I have angle B, so that has to be the angle over here, which means little b has to be over here. And then it's like Pythagorean theorem, b squared equals a squared plus c squared minus 2 times these two guys, cosine of the angle I know. Okay, write that down, plug everything in very carefully, show your work so I can give you partial credit on your test if you make a little mistake, which is so easy to do. Follow order of operations. You cannot do 136 minus 120 is 16 and then multiply times cosine. You're violating PEMDAS. You're violating order of operations. Multiplication comes before subtraction. Okay? Solve. Find your answer, little b. Then we say, okay, as soon as we find one thing from law of cosines, plug it in to law of sines. And now you have one of your fractions with everything known. So now you can find angle A or angle C. But this is where you got to watch out, because your calculator might mess up. It might give you an acute angle when you're looking for obtuse angles. So find the smaller one first, which is angle C. You should not find angle A first. Okay? Now, there's something in this problem that gives away that it actually doesn't matter this time, but this is the safe way of doing it. Find angle C first. I guarantee this is going to be something that people mess up on their test, and I'm gonna for sure put a problem in there that catches you if you're not doing this in the right order. Okay? And even if it works out and you don't do it in the right order, I'm going to take off points because I think you just got lucky. Because I'm thinking you weren't paying attention about it. So you got to find law C first. It's the small. It's not necessarily the smallest angle, but it's the smallest of these two angles. Okay? Smaller of two angles, two unknown angles. Find the smaller one, okay? Which is across from the smaller side, okay? That basic idea. So find this. So we can mix and match. We're going to put these in here. We're going to cross multiply. And in fact, I would encourage you to try and keep this as exact as possible. Now, the problem is that angle side B, that's a mess. Whatever, that's fine. Go ahead. Now, you should be keeping more than 3 decimals, though. Remember that idea that you need more than 3 decimals in your work for your final answer to come out 3 decimal accurate. And now we do want 3 decimals, rounded or truncated, is the general rule in calculus, unless the directions say otherwise. Now, once you find this angle and you already have one of the other angles, don't do law of sines again. You could, but gosh, it's just the easiest way is to do 180 minus the two angles that you know, right? Just do that. Sum of the angles of the triangle out to 180. Always do that. Plus, if that last angle is obtuse, this will give you the right answer. Your calculator will not. Okay? So this is how we avoid getting wrong answers from our calculator. So that's how you do it. The next one is the ASS situation. Okay, so they give you these. I would just draw a generic triangle. Okay, let's say we don't even know what the triangle looks like. Try not to make it look like a right triangle or an isosceles triangle or an equilateral triangle, because that might make you think that it's something it isn't. So put a capital A on one of them. Put a capital. Now, I kind of want the known sides to be, I like the known sides to be over, up here. I mean, you put them down here because I like to envision this last side swinging. Okay? So this is capital A. Little a has to be from it. Big B is across from little b. That means this must be big C and this must be little c. And you can draw this a lot of different ways, but it should come out right. So this is the swinging side, right? So we say, oh, this is angle side, ASS. Oh no, this is the ambiguous case. We might have one solution, two, or none. We need to figure it out right now. Let's predict it. So what we're going to do is we're going to calculate the height, draw the height in. Now the height needs to be the height between the two known sides, okay? Because this is the swinging side, okay? This has to, now the other quick check before we even do this is if this is bigger than that, it's one solution. Don't even worry about it, okay? But, and by the way, the one solution version, anyways. Okay, so it's one solution if this is bigger than this, but it isn't, so we need to calculate the height. So now the height is, you don't need to memorize this formula, just basic trig. Okay, if I want to find this, and I know this, and I know this, and then that's opposite of hypotenuse. So sine of 35 equals the height over 18. So h equals 18 sine of 35 degrees. And so h equals 10.324. Okay? So I say, oh, well, this is longer than that. So since a equals 14 is bigger than h, which is 10.324, it's two solutions, right? Two solutions, which is usually going to be the case. Because the one solution case is the right triangle, which is a weird case. And the no solution case is just weird because you don't even get a triangle. So this is probably the most common outcome, is that you get two solutions. So we know we're going to get two solutions. Okay, keep that in mind, because that's going to really affect how we do this. Now we go ahead and we jump into law sines. Sine of A, which we know sine of A is 35 over little a is 14, equals sine of B, which we don't know, over little b, which we do know is 18, equals sine of C, which we don't know, over little c, which we don't know. Now when you look at this, you say, well, do I have to use law of cosines? No, if you know one of these fractions with all the numbers, you're good on law of sines. And we can't find angle C or little c. So I know I always said, let's find the smallest angle first. Well, you really have no option here. You got to find angle B first, because big C and little c, those are different values. We need one unknown. If you have two unknowns, then you're stuck for solving. So we're going to find angle B. So angle B equals inverse sine of, and this is work I want you to show, 18 times sine of 35 over 14. This is the exact answer for angle B. I want to see this in your work, okay? Now, then you're going to calculate on your calculator, and your calculator is going to always give you the acute angle, okay? Now, let's go back to the notes real quick. Let's go back to the notes real quick. And let me show you what's happening here. So your calculator, there's these two different possibilities, right? And this is going to be the next angle you try and find. And this is the one your calculator is going to give you, the acute one. This is the obtuse version right here, right? Your calculator is not going to give you that. Now, once you find the acute one, we're going to use this other idea from geometry that says, oh, like these two different scenarios, look how they create like an isosceles triangle situation, right? Which means that these two angles are equal to each other. So once you find this one, then you know this one, and you can find the obtuse version, which is the second solution, by subtracting it from 180, because they always form a straight line. So that's how we're going to find the second solution. So the second solution, this is the first solution. The second solution, which I might call it angle B star, okay, just to differentiate which one is which, because there's going to be two different sets of answers for a bunch of stuff, is going to be 180 minus the first angle B. Okay, this is the first angle B. This is the second one. And that's going to be 180 minus whatever that answer is. Okay, and so then that's angle B star. Okay, so now we got to find angle C, and it's the last. We already know two angles, and so we always just use some of the angles of the triangle to find the last triangle. One, to protect us from bad answers from our calculator. Two, just because it's easier. So we do 180 minus angle A minus angle B, and we get angle C. But we also got to find the angle C star. Okay? And that one's going to be 180 minus angle A, which is true for both of them. It was the original information minus angle B star, the one you just found. So this is the second solution, okay? Then we got to find little c. So we go back up to law of sines, and here's little c, right? So at this point, we have big C. We plug it in up here. And I personally would try and avoid using the new angle B as like I would try and use this one. You could use this one now because you have angle B, but this is just simpler and cleaner. So I'm going to be like, all right, well, angle C or little c is going to equal, you could flip both sides upside down and then multiply by sine of angle C, which is that new angle you just found, 97.524, and you should really carry some extra decimal places, okay? And that gives you little c. But you got to find little c star, the second solution, right? So you go back up here and you say, okay, well, little c star is we're going to use 14 over sine 35 again, but it's going to be sine of angle C star, 12.476. So you got to use the second solution information that you're getting to get the other parts of the second solution. So this is C star right here, okay? So now you can group them together. This is solution one, this is solution two. It'd be good to kind of like say, all right, here are the two separate solutions, and these are the star ones. Okay, so that's how we do it. All right. Now here's a tricky one where I think I'm saying it's tricky because your calculator can give you the wrong answer. Okay. So we have this problem right here. I'm just going to act like I'm trying to draw the triangle. Capital A, we don't know. Little a, we know 7 across from it. Capital B, we don't know. Little b, we know is here. And then capital C, we know is 24 degrees. And little c is right here. So you can draw the triangle however you want. I made mine look a little potentially different than the original one. I just started drawing it. And then we say, okay, well, which situation is this? This is side, angle, side, side, angle, side. So we don't need to worry about two solutions or whatever. There should be one solution, okay? Now, it is possible in these problems you could get no solution just because the information they give you can't possibly create a triangle. That is possible. And so usually what happens is something logically just doesn't make sense. Like you get an angle that's more than 180 degrees, or you get a negative angle where the two angles you have add up to more than 180 degrees. Well, that's just not possible, right? because you got to have three angles to make a triangle, and they have to add up to 180. Can't be more than 180. Okay. Now, I'm going to set up law of sines. Sine of angle A, which I don't know, over little a, which is 7, equals sine of big B, which I don't know, which over little b, which is 6, equals sine of C, which I do know is 24 degrees, over little c, which I don't know. So then I look at this and I say, well, can I use this to find any of these unknowns yet? Can I match two of these together, any of them, and have one unknown? Nope, nope, nope. I got to do law of cosines, okay? So I only do law of cosines if I have to, okay? And I only do it once. So now I decide, well, which version of law of cosines do I need? I don't memorize them. There's a pattern, but I need to recognize, well, what's the pattern? Well, whichever angle you know or you're looking for, that's the angle that has to be inside the cosine. So as soon as you say, oh, well, capital C is inside the cosine, then little c has to be on the left by itself. And then the other two sides left over are the ones that are going to be squared, plus squared, minus 2 times those two, and then it's got to be cosine, okay? So then you plug everything in, and then you take the square root of both sides, technically plus or minus, but it's only going to be the positive because we're dealing with actual real triangles here, which should have positive lengths of sides. And so then we plug this into our law of sines, and now we can use law of sines. You don't want to use law of cosines again if you don't have to with this messy answer. So you plug it in here and you say, okay, well, should I find angle A first or angle B first? Now, some people instinctively will be like, well, I'm going to find A because A is first in the alphabet. And so they find A, and then the calculator gives them this answer. But is it this one or is it this one? Is it an acute angle or is it an obtuse angle? We really don't know. And I don't think, maybe if we did a bunch of work, we could decide up front if the answer should be obtuse or acute when we're done. But it's easy to avoid this, okay? Now, the calculator gives positive principal values for inverse sine, which are negative 90, 90, which is only going to give you the first quadrant, okay? You'll always get a value between 0 and 90 if you do inverse sine of a positive number, okay? So, and even if it's supposed to be obtuse, it's going to give you an acute. Now, let's try the other way. If we found angle B, so then we find angle B, and just by using some of the angles of a triangle, and we get two different possibilities. Well, which one is it? Which one is the correct one? Okay? And so what I'm trying to show you is that we should make sure we get the right answer to start with. Okay, so we want to always find the smaller of the two angles. Okay, which one's smaller, angle A or angle B? Angle B, because it's across from the smaller side. So we should not have found angle A first. Okay, we should have found angle B first. Okay, we should have found angle B. So I didn't really show the work for you here, but this is the way you should do it. You should find angle B first, since it must be acute because it is the smaller of the two angles. It's not necessarily the smallest angle of the whole triangle, but it's the smaller of the two unknown angles. And that means it has to be acute because there can only be one obtuse angle in a triangle. There's always two acute angles for sure. So even if it's not the smallest, if I know it's at least smaller than one other angle, it's got to be an acute angle. And then I can feel confident that my calculator is going to give me the right answer. And then I always use the sum of the angles of a triangle to find the last angle for all these problems. And that will always be safe because that will always give you the largest angle last, the obtuse angle, and you're not relying on principal values from your calculator. So this is the way you need to do any of these problems, is find the smaller angle. Anytime you have a choice between should I find this angle or this angle first? Well, I can find this one or I can find this one. And you could do all the work and everything will seem fine, but you will have the right answer. Okay. So this approach was wrong. We did that correct. Okay. But then finding angle A next was wrong because this ended up being the right answer and our calculator wasn't going to give it to us. Okay. And you wouldn't know. You could say, well, it could be this, but then how do you decide which one it is? Let the calculations give you the right answer. This is the right answer, okay? And one way that you can confirm it is by plugging all your answers back into law of sines, and they should give you the same thing. And this doesn't give you the same thing, so it's actually wrong. This one tells you it's right. You don't need to do this though. If you force yourself to find the smaller angle, force your triangle to always find acute angles for you on these solving triangle problems, then your calculator won't give you the wrong answer, and you'll be confident that you have the right answer. And use the sum of the angles of a triangle to find the last angle. Okay? So I kind of feel like these problems are tedious, and there's a lot of little tricky things in them. You've done this before. You were taught how to do this in Algebra 2 at the very least. You probably got to do it again in pre-calc. There's nothing in here that you would have learned only in pre-calc. You should have known this stuff from Algebra 2. So let's get good at this again. Try the homework. The homework is on the back of the other note sheet. And draw pictures. My advice is to draw pictures of every one of these problems other than 1 through 3. 1 through 3 is just practicing stuff on your calculator. And by the way, on the solutions, I believe I have the wrong answer for number 3. The answer should be root 3 minus 1 over 1 plus root 3, or if you simplify it, you get positive 2 minus root 3. And I think I had a slight variation of that on the solutions that are online, but I'm not going to go back and change it at this point. So this is what the answer should be for problem 3. That's a tricky problem on its own if you can't figure it out. Now, actually, these are no calculator problems, the first 3, okay? The rest, we're going to do calculators and degree mode only. Okay, the rest of the problems are going to be calculator. 3 decimal accuracy, rounded or truncated to 3 decimal accuracy. Draw pictures. Draw a picture, 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 draw a picture. It doesn't need to be a perfect picture. Just a picture to label things and get them organized and to be able to decide, is this SSS, ASS, SAS, and then start showing your work. Okay, you're probably gonna have to write small to fit your work on these problems. Okay, and then we're not actually technically solving the whole triangle on these. You're just finding one unknown side, but you might have to find some other unknown things before you get to these correctly, because we've talked about how you got to find the smallest angle first, and sometimes the information given to you only allows you to find certain information next. So try to do your best.